In this video, we will discuss individual types of storms and how to identify them. Thunderstorms come in a variety of shapes and sizes. The typical pop-up type storms in the summer heat tend to be brief and localized, and what we call a pulse thunderstorm because it forms quickly and can die just as quickly. If they are severe, it tends to be short-lived. Groups of thunderstorms can form into a cluster or into a squall line and tend to be more persistent. Supercells are the strongest type of storms, and their intense updrafts can cause the severe weather threat to persist for an extended time. These types of storms pose a significant threat for all types of severe weather, including tornadoes and very large hail. Squall lines are not uncommon in our area. Damaging winds tend to be the primary threat from them, though they can produce hail as well. Tornadoes may form in isolated locations along the line and may briefly be strong. However, the winds can be extreme and long-lasting, such as in the case of a derecho. Quite often, a squall line will produce a shelf cloud. Warm, moist air flows into the cloud, with cooler air coming down with the rain. Shelf clouds can look impressive in their own right, and sometimes have cloud fragments that can be mistaken for wall clouds or funnel clouds. The key to distinguishing them is to look for rotation. Here's a time lapse of the arrival of a shelf cloud. To the untrained eye, this can look scary, but the lack of a consistent rotation confirms the lack of a tornado threat. However, strong winds can accompany them. Note that not all squall lines produce shelf clouds. For example, the derecho from June 29, 2023 did not have a particularly well-defined shelf cloud with it. Here is another example of a shelf cloud. Note that after the shelf cloud goes overhead, there is lots of chaotic motion, but no consistent rotation. Supercell thunderstorms are responsible for most significant tornadoes in the United States, as well as hail larger than golf balls. These are the types of storms that can be easily seen from a far distance. From that range, you will be able to pick out features such as the anvil, an overshooting top that punches through the anvil, and nearby lines of clouds called the flanking line. As the storm gets closer, you'll see more of the severe aspects closer to the ground, such as wall clouds, inflow, the rain-free base, and tornadoes or funnel clouds. While thunderstorms contain updrafts, the key with a supercell is that the updraft is rotating. As the storm grows, the rotating updraft is dragged upward. In this video, you can see a real-life example of a supercell. This is a classic supercell example on radar. This particular one shows a tornado with the classic hook echo on the left and the velocity image showing strong rotation on the right. Remember that to interpret the velocity image, you need to know where the radar is located. In this case, the radar is to the east of the storm. In a classic supercell, the area known as the rain-free base tends to be easily distinguished. However, our area typically has what we call high precipitation supercells, and the area you would have associated with a rain-free base will actually have rain with it. Note that it will be tougher to pick out some of the cloud-based features cleanly. A wall cloud is a persistent lowering of the cloud base. It may or may not be rotating. The key is consistent rotation. This area is one to watch for potential tornado or funnel cloud formation. Here's a video of a wall cloud in a high precipitation supercell. The wall cloud is on the right. Note that it does exhibit some weak rotation near the end of the video. A funnel cloud is a rotating column of air not in contact with the ground. You need to be able to see the ground to determine if it is a funnel cloud or a tornado. Trees, buildings, and crops can block your vision. When calling in this report, make sure to clarify if you can see the ground or not. A tornado is a rotating column of air in contact with the ground. Sometimes it is hard to tell if this is the case, as there may not be a visible funnel extending from the cloud to the ground. Watch for signs of rotation right at ground level. If the rotating column is in contact with the ground, then it is a tornado. Tornadoes come in a variety of shapes and sizes. Size is not necessarily an indicator of strength. Tornadoes are rated on damage intensity, so if it causes no damage, then the strength cannot be easily quantified. Another tornado often develops a few miles downstream, east or southeast of the dissipating one. If a tornado is dissipating, be sure to watch the area downstream for a new development. The rear flank downdraft can be a visual precursor to tornado development and produces strong winds. It is located near the hook echo on a radar image. When observing a rear flank downdraft, watch for a clear slot to the left of the wall cloud and the horseshoe-like appearance of the cloud. Here is the evolution of a rear flank downdraft. Note the clear slot to the left of the wall cloud and the horseshoe-like appearance of the cloud. High precipitation, or HP supercells, often have a kidney bean shape on radar. The area of rotation is in the notch. With HP supercells, it tends to be hard to pick up critical features without being too close to them. HP supercell cloud bases are often difficult to see unless you are very close or directly in the path of the rotation. This is dangerous and not recommended.